We want to determine y prime, or the derivative of the given function. Notice this is a pretty complicated function, so what we can do is take advantage of the properties of logarithms to help us determine the derivative. So what we can do is take the natural log of both sides of this equation, and then we can apply the properties of logarithms given here to expand this logarithm. Let's first eliminate this quotient by writing this as a difference of two logs. We would have natural log y equals natural log of x to the fourth times the square root of x minus 3 minus natural log x plus 1 to the third. Now let's expand this logarithm here. Since we have a product of two functions, we can write this as a sum of two natural logs. So we'd have natural log y equals natural log of x to the fourth plus natural log of the square root of x minus 3, which I'm going to write as the quantity x minus 3 to the 1/2, minus natural log the quantity x plus 1 to the third. And the last thing we'll do here is use the power property of logarithms. So we'll move the exponents to the front and multiply it by the natural log. So we'll take this 4 and move it to the front. We'll take this 1/2, move it to the front, and we'll take this 3 and move it to the front. So we'll have natural log y equals 4 natural log x plus 1/2 natural log x minus 3 minus 3 natural log x plus 1. So now we'll take the derivative of both sides of the equation with respect to x. So when we differentiate natural log y with respect to x, we're going to have 1 over y times dy dx. We have to apply the chain rule. So we have 1 over y times dy dx is going to equal 4 times the derivative of natural log x, that'll be 4 over x, plus 1/2 times the derivative of natural log x minus 3. We may be thinking the chain rule here, but if u is equal to x minus 3, u prime would be equal to 1. So the derivative of natural log x minus 3 is just 1 over x minus 3. So we'd have 1 over 2 times x minus 3 here, minus 3 times the derivative of natural log x plus 1, which is 1 over x plus 1. Again, if we apply the chain rule, u prime would just be 1. Now the next step is going to be to add these fractions on the right side. So we have to obtain a common denominator, which will be 2x, x minus 3, and x plus 1. So we need to multiply this fraction by 2, x minus 3, and x plus 1 on both the top and bottom. We'll have to multiply the top and bottom by x times x plus 1 for this fraction. And here we'll have to multiply by 2x and x minus 3 on both the top and bottom. So notice how all the denominators are now the same, so we can try to combine the numerators. So we'll have 1 over y times dy dx is going to be equal to a fraction where the denominator is going to be 2x times x minus 3 times x plus 1. Now we'll multiply these two binomials and then multiply that by 8. So x times x is x squared times 8, that's 8x squared. Then we'll have plus x minus 2x, that's minus 2x times 8, it's minus 16x. Then we have negative 3 times 1, that's negative 3 times 8, so we'll have minus 24. Here we're going to have x squared plus x. Here we need to be careful because we're subtracting, so we'll have 3 times 2x, that's 6x. 6x times x would be minus 6x squared. And then we'll have 6x times negative 3, that's negative 18x, but we're subtracting it, so it's plus 18x. Now let's take this to the next slide and simplify the numerator. Here we have an x squared term, an x squared term, and an x squared term. So we'll have 9x squared minus 6x squared, that's 3x squared. Now let's look at our x terms. We have negative 16x plus x plus 18x, that's going to be plus 3x. And then we have minus 24. Notice how there is a common factor of 3 here, so we're going to factor this 3 out, but we also have to solve this equation for dy dx. We'll do that by multiplying both sides of the equation by y. If we multiply this equation by y, the y's will simplify out, so now multiply the right side by y. So if this simplifies out, we're left with dy dx equals y, which is the original function given here. So we'll have x to the fourth times the quantity x minus 3 to the 1/2 all over x plus 1 to the third. Times, again, we're going to factor this numerator, so we'll have 3 times the quantity x squared plus x minus 8 all over 2x times x minus 3 times x plus 1. So again, here we multiplied both sides of the equation by y to solve for dy dx, and y is equal to this quotient from the given problem, and then we're going to multiply it by this fraction here. So now we need to simplify. Notice how one factor of x is going to simplify out here and here, so this will be x to the third. Then looking at the factor of x minus 3, this is x minus 3 to the 1/2, this is x minus 3 to the first. So this will simplify out, and this will become x minus 3 to the 1/2 power. And then notice how we have 4 factors of x plus 1 in the denominator, 3 here and 1 here. So we'll have 3x cubed times our trinomial. Our denominator is going to be 2 times 4 factors of x plus 1 and the quantity x minus 3 to the 1/2 power. So you can see this one was quite a bit of work, but this would be our derivative function by performing logarithmic differentiation. I hope this was helpful.